Hello everyone, today I'll show you how to make a PCG framework based tool that will place objects along the spline to create fences that will connect properly on each post, that will enable you to place objects along a line with random rotation and placement. It will automate the work on your environment creations and save you a lot of time. And please stick to the end to see how every one of these examples is created. I just record this at the end of the tutorial so you can be sure what you will get to learn into the tutorial, to learn till the end. So now I'll go back in time and start from the beginning, so please enjoy. If you hate manually placing fences or other objects along the path in your game environments, I will show you how to make a PCG tool to help you automate this process. This will be my first procedural content generation framework tutorial, but you can expect more in the future. Working as a single dev requires you to have access to tools that will help you automate any process for the level creation, because this is a very big task for a small team or a single developer. There are some tutorials for placing fences. I tried to find one that will do the job for me, but every tutorial that I found have one big problem, that when your path is making a turn, the different parts of the fence are not connecting properly. And I wanted to create a tool like you can see here that is connecting the fence properly on each turn in my spline path, so I can use not just the straight path as most other people show, but a curved one. I'll show you how to create this tool. Let's first start with how most tutorials show you to do this task. First, create a blueprint. Let's call it PCG underscore fence. Let's actually put a BP in front, so it's a blueprint naming. Now, inside this blueprint, we'll create two components. One will be the spline that we'll use to generate the fence. So click on the add button here on top of the components panel, add a spline, then add a PCG component. If you don't have this PCG component in your list, you need to enable first the framework. So go to edit plugins, then search for procedural, and you need to enable the procedural content generation framework and the procedural mesh component. Then you'll be required to restart your Unreal Engine, and after the plugins are loaded, you can create a PCG component in your blueprint. When you select the PCG component, you need to add the PCG graph here into the details panel for it. We don't have any PCG graphs created yet, so right click in your content browser, then choose PCG and PCG graph. Let's call it PCG fence, and select here the PCG fence graph. In your blueprint PCG component details panel. Now, after you've done here, you're ready for now with this blueprint. Let's go to the PCG fence graph. Now, inside this PCG fence graph, we will not use this input and output. They're used when you're creating a subgraph or other things like that. Don't worry about them for now. We'll sample the spline from our blueprint and we'll place a fence static mesh object along that spline. So right click here, choose spline sampler. For the spline sampler, you'll need the spline. So right click, choose Get Spline Data. In the Get Spline Data tag, the actor filter will be self. This PCG will be placed inside our blueprint class, so the self will refer to this class and it will find the spline in our class. Let's connect this to the spline sampler. Then we'll use this spline sampler with the option not subdivision by distance, because our fence component will have fixed size, so we'll base the placement on this distance parameter. So on every, let's say, 100 centimeters, we'll place a spline object and we'll place it by static mesh spawner. In the static mesh spawner, create a new mesh entry by clicking the plus sign here next to the mesh entries. Open this descriptor and in the static mesh select the fence that you want to place. So most tutorials that I found use this Quixel Megascans fence. Let's save and test our blueprint into our level. When we drag the spline, it is automatically placing fences each 100 centimeters. Let's change this parameter to 200. We need a little bit more, 250. Okay, now it looks fine for the distance. Because if we do it with bigger distance, the bottom board will not reach the next post. So 250 seems fine to me. And it looks pretty okay if you're drawing a straight line. But if you make your curve at an angle, you can quickly see that these fences are no longer attached to the next one. And I've seen some people fix this by moving this fence along the spline to try to mitigate this problem. Let's try this. Transform points. We'll transform the placement of this fence with half of the length, so it was 250, so let's move it by 125, negative 125, half of the object's length. And this seems to do the trick for this type of fence. But you can see it's detached here, and if you make the angle even more extreme, it will detach more. And even in the place that it looks like it's working fine mostly because this fence is just some random blocks put together. If you use other mesh for the fence that's a little bit more defined in its shape, let's use, for example, this fence. Now we'll have a problem with the length. It's a bigger fence, so I believe it was 295. And you immediately see that even on small angles, our fence doesn't seem to attach anywhere properly. And in my example here, like I want the tool to work, I want everywhere the fence to be attached to the next post. So how to fix this problem? Obviously, let's just try this solution. Change this option when we change the length of the fence. So 295, half of it will be minus 147. it seems that it's not helping at all. So this is not proper solution for fences that are not crude looking like the one that's used in most tutorials. To fix this, we'll need to create a logic that finds the next point and orients our current point to directly rotate the object to the next point. We can do that by creating our custom blueprint node, and we'll connect it here. Right click in your content browser, create a blueprint class, make it of a type PCG blueprint element, and let's call it orient point, for example. Now here, after we sample the points, we don't need this transform for now. We'll create execute blueprint node, and this blueprint will be orient point, the one that we created. So create a execute blueprint node and choose the orient point blueprint. Now this still doesn't do anything. We'll need to edit this blueprint node to incorporate our logic. So go inside our orient point blueprint node, and what we'll need to do here is override some function of the base blueprint element class. So into the functions panel, choose override and choose execute with context. This is the function that will be executed by our blueprint node. To start, we'll get inputs, and we'll get this input here. It will return a data structure. For this data structure, we'll get the first element. We'll break PCG tag data, and we'll use this data to cast to PCG spatial data. So connect our graph here. We'll convert to point data with context, and for the context we need to use the context that is delivered to our blueprint. And here we'll execute the point loop function. We'll override also the point loop body. Let's go back here and execute point loop. We'll connect the point data here, and for the context we need to connect the context from our input. And here, in order to deliver the final data out of this blueprint, we need to make PCG tagged data. We'll make array from this, and we'll make PCG data collection. This is our required output. So this is the structure that you need to have in order to execute some logic for each point and deliver back to our blueprint. Let's compile and save this, and let's go to the point loop body function. This is our point loop body currently. It's not doing anything, it's not returning any data, and that's why we have an empty scene here. We need to get the points from the data provided here and return the modified point with proper orientation. So let's add some space here. Let's disconnect this node and start from the beginning. Go to the point loop body beginning node and first get the data we'll get points. This will give us an array with all the points in our spline. We'll find the current point that we are executing this point loop body for. It's executing for each point, starting with the first one, next one, and till the last. So we'll find the point that we are currently executing for. Then we'll add one to have the next point. We'll check if the length is exceeded, because we cannot add another point after if we are on the next to last point, and if we add one we'll find the last one, but if we're on the last one and we'll add one, we'll not find anything. So we need to check if this is smaller than the length of our array of points, so the sum of all the points on top of our spline. And if only if we are meeting this condition, we'll execute the code after. So let's create a branch node by holding B and clicking into the graph. Connect this branch. And the condition will be if we are not exceeding the length of our array. And what we'll do is we'll set members in PCG point. The PCG point that we'll need to set the members are the current point that we're executing. And we'll after this return the value from our blueprint PCG node, and we'll make sure to make this boolean true, return value, compile and save, and this will return the objects here. They don't have the proper orientation because we have not set the logic to set this PCG point members properly, but what we'll need to set for this point is defined here. Select this set members in PCG point, and into the details panel choose properties and mark transform, because we need to rotate our object. Split this pin and you have transform, rotation and scale, location, rotation and scale properties. We'll change the rotation. The other two will be derived by the original point. So let's get this original point data, drag from the in point from our start loop, break PCG point, and when we break it, we have the transform and the density. We'll get the transform and break the transform. This returns the location, scale and rotation. Location and scale will be saved automatically into the new point, and rotation will calculate based on the next element into our array of points onto our spline. When we add one, let's use this to choose a point from the array. So from this get points array, we'll get the point with the index of current +1. We calculated it already here. So this is our original point, and this is our original point data, and this is our next point data. We need to break that as well. We need to break this transform as well. And to get the new rotation, we need to subtract from the position of our next point to the position of our current point. So this is the next point. I'll subtract the location of our next point from the location of our current point, and then I'll make rotator from X. This will get the vector from the two positions and will make it into a rotator to be able to be used here into our transform rotation. Let's compile and save. And you see that now every object of our fence is properly oriented to the next point. Add more points and see how this is behaving. It's properly orienting the fences, but when we have a case like this, when we have the fence too wide to fit our curve, we need to fix this problem by scaling the fence to fit this gap in between, because our PCG graph is placing the points from a fixed distance along the spline, and this spline is taking longer path to reach the next point here. So we have set this value to, I believe, around 300 units, so 3 meters. And the spline is taking 3 meters to here, but the object is taking a shorter path, and that's why it's not connecting properly to the next point. It's overshooting by the amount. That's the difference between this line and this straight line. So we need to calculate this instead of just placing it with the original size. And into our point loop body, instead of using the original scale, I'll disconnect this. I'll split this pin. We'll use the original scale in Z and Y, but the X-axis, which is along our spline, we'll calculate later. So the original scale from our original point is here, the top one. We'll split this pin and connect the Y and Z directly. And for the X, we need to divide this by the length of our fence, which in this case is 295. Let's connect this, and when you compile and save, actually I made some mistake. Yeah, I don't need to calculate this based on the scale, because this is just a multiplier for the X. I need to actually calculate from the vector that we're creating here between the two posts. I'll get this vector length, and I'll divide this by the length of our object. So compile and save. And now here I have fixed the distance between these points. And if you're not creating splines that do, for example, this, which they leave so little space between the lines that it's hard to place an object between them, it will look fine, but you can always just fix this by moving the point to be next to the post, and this will fix the problem with the little mesh in between. Just avoid having so sharp angles that you cannot fit, but even in this case it's hard to see that you have a problem with this fence. So I believe it's working pretty good in that case as well. So we're pretty close to the desired behavior, but what happens if we decide that we'll put another object that's not with this length. So let's change the mesh here into our PCG fence, mesh spawner. I'll spawn maybe that one. That one is too hard to notice, but let's use the one from Quixel Megascans. So this mesh is shorter than the one on the other fence, and now we are not connecting the bottom beam to the next post. We need to change the distance increment here, 250. And when we do that, we are scaling this post to a smaller size, and it's still not connecting to this next post. So we need to have a variable that's changing both this one. Let's change to 250. And this one here into our point loop body. We'll need to divide 250. Compile this. And now we have the proper size for each part of the fence. So how can we do this? Let's add a variable to our blueprint. Let's open our blueprint. And here, let's create a variable called segment length. And it will be of a type float. So segment length with type float, compile this and save. It will be a public variable, so click on the I, compile and save. Now, when you select your PCG blueprint in your level, you have this segment length variable. Let's not start with default value of 0. Let's have 200, 2 meters. And it's not changing anything into our scene because we have not connected it anywhere into our PC graph. So let's go back to the PCG fence. Here, instead of using a fixed distance increment, we need to use our variable from our blueprint. So right click into the graph and use get actor property. The actor property needs to have the same name that you have the blueprint variable here. So segment length is the name. Here into the property name, input this segment length exactly as it's on the blueprint node. Click on this arrow to show all the properties for the spline sampler and connect this to the distance increment. That way we are now using the variable into our blueprint. So let's go back to the level, select our blueprint and change this to the length of our segment. So we're properly now changing the increment between our meshes, but we're not properly scaling them because we are still scaling based on the 295 length that we entered before. If I enter 295, this will have the proper original size. But we need to make sure that we're always using this property here. Our orient point function needs to accept a variable that's this segment length. Let's create a variable here, call it mesh length, and it will be type float. We'll make it again public. We'll compile and save. And if you go back to the PCG fence graph, we'll have now this mesh length variable here. We'll copy this get actor property and connect to the mesh length. Now inside our orient point blueprint. Instead of using this fixed number here, we'll use the mesh length variable, compile and save. And now into our blueprint, we can change in the level the segment length, 250 for example. And now we have a matching fence with the size and the placement of all of the posts. If we change the mesh into our blueprint, let's go to the PCG graph, change the mesh here to a different one, for example, the one we had before, this one. Now this one is longer, so 295. It's now properly connecting every time. We have a little disconnection here, so every time you change the mesh, it's expecting that the beginning of the mesh is matching with the beginning of the spline. So this mesh is extending a little bit back from the spline. We need to move it. So into our PCG graph, if I had a transform node, transform points node, connect the orient points output to the transform points, and then I'll transform the points so that my beginning of the mesh is matching the beginning of the spline. So I'll offset them in X with 10 units, 15 units maybe. And now I should have a better angle here, so it's better matching each post. And the problem with this setup is that every time you change the mesh, you need to offset this manually, and also for changing the mesh you need to go to the PCG fence and change the mesh here into the static mesh field from the spawner. It's not very good workflow. The best workflow, in my opinion, will be just to drag the blueprint on the level and choose the mesh and align with this transform point for each object in the scene separately. That way you can use this same blueprint for different meshes and different lengths of this fence. So let's add into our blueprint two other variables. One will be the mesh that we want to use. We'll make this type static mesh, and it will be static mesh object reference. Then create another variable which will be mesh path. This will be soft object path, because you cannot connect directly static mesh into your PCG blueprint nodes. You need this mesh path variable instead. We'll make this static mesh variable public, and we'll set the value of the path for this mesh into our mesh path variable. We'll create another variable here and call it location offset. It will be of type vector, because we can offset in X, Y, and Z directions. So in order to save our mesh into the path of our mesh into the mesh path variable, go to the construction script of our blueprint, and let's set this mesh path by out dragging here into the graph the mesh path variable, control drag the mesh variable, and we'll get soft object path for this mesh and set it into our mesh path variable. Let's compile and save. Let's copy the name of this mesh path and back into our PCG fence. Instead of setting our static mesh manually here, we need to change the static mesh spawner type from this weighted to by attribute. The attribute name will be, let's say, mesh path. We need to add attribute, and let's call this attribute the same way that we said here, mesh path. So mesh path. Let's click here from source parameter, and the source parameter we need to get actor property, and the actor property will be the one that we created into our blueprint, mesh path. Connect it here. We have some error. Attribute none is not. Actually, I made a mistake. This out attribute name should be actual attribute name. So we'll be placing based on the path to our mesh. We are saving into our blueprint. We are choosing it into our blueprint. We are saving it into the path variable, and we are here adding a mesh path attribute to our points and using this attribute here into the attribute name with the type PCG mesh selector by attribute, and we'll be placing the objects there. So if I save this, and now my blueprint has a mesh selector here. Let's choose a fence. Let's choose this one. Now let's change the size to 250, and it's now properly connecting all of my points, even on the bends. It's scaling them to much better the transition between the points. I need to remove the offset, so I have not finished the setup for the offset. Let's go back to the blueprint class. Let's make this location offset public variable so I can set it from the level. Let's go into our PCG fence. We need to get actor property, location offset, and we need to pass this property to, actually we will not do it in the orient points, we'll transfer them after that. So instead of transferring by this fixed amount here, let's open this node and connect this vector with the offset to the offset min and max here. Let's save. And now I can change the offset here in my level for each spline separately. So if I copy the spline, if I change it, if I change the mesh to the this needs to be 295, and I need to have an offset of 15 centimeters. I'm using the same component to place completely different type of fences, and they're all connecting properly into each bend of my turn. This, unlike the simple fence generation tools that I have found in other tutorials, you can use this to place other type of objects. For example, let's place this concrete block instead. And this concrete block, if I place it, for example, 100, 150, like this, you can see it's not a fence, but again, placing objects along a spline with proper orientation and proper placing. What about if I have this spline like this? For example, I have just a straight line, and I don't like that every single object is placed exactly on the same line. This is not happening in real life for this kind of objects that are just placed along the path. So I need to add some rotation here. And if I go to my PCG fence graph and I enter some random rotation into my transform points node, for example, here rotation min -15 and rotation max 15. It's too much, but let's say -5 and 5. I have some variation here, but I'm breaking all of my other fences by doing it into the PCG graph itself. So we need to do the same thing like we did before for the offset, for the translation. We need to do it for the rotation now. And to be able to rotate our object and as well add an offset, we need actually to have two values. Because, for example, if I have a fence, okay, this fence, you can see even if I change the size to 500, 550, 600, let's say. Okay, if I'm placing this with 600, it's not properly placed along the corners because the pivot point is not matching with the beginning of the spline. I can try moving it here by 600 and I have a better placement, but still what I would most likely be better with is just rotating it along the axis. And then if I want to add some random rotation, I can use another parameter. So because of this, I'll make two other variables here. One will be rotation offset, and the other will be random rotation. And they'll both be of a type rotator. Compile and save. Let's make them public. So now into my level, I have a separate control for the rotation offset and random rotation for each of my different fences. So I'll go back to the PCG fence. Instead of transforming all my fences with this parameter here, I'll need to get a property and use that. But the problem here is that first I need to rotate my objects. So let's do another transform points. Let's connect to this one, and here into this transform points, let's move this to have a little bit more space. Into this transform nodes points node, I'll get actor property. I'll get the property called, let me remember the name, rotation offset. It's saying that it doesn't have this property. Let's just copy it. Rotation offset. Okay, now it's fine. I have it misspelled. And let's connect this to the rotation min and rotation max. So this rotation offset property will be great instead of adding this location offset when my object has the proper pivot, but it's just rotated the other way. I can just rotate here my object 180 degrees, and now I have perfect placing along the spline. And if I go back to the other example with my concrete blocks, so choose the concrete block element. This is another one, but let's say 400, 320. You can see that it's offset from the beginning of the spline, so let's add the location offset. 125. Now it's properly placed. Let's add a turn to our spline to just make sure everything is placing correctly. And now I don't want to have this exact straight line. I need to have a random rotation. Let's do this actually into our blueprint. So when we create the random rotation, when we enter the random rotation values, let's continue into our construction script. After we save the mesh path, we'll get this random rotation value that we have created. We'll split this pin to have the X, Y, and Z rotations, and we'll divide each by 2. That way, after we divide it, we'll make sure that we have one for the positive direction and one for the negative direction. So make rotator again, connect this, all of these values, and with this rotator, I'll have the half of the rotation in one direction, and I'll multiply this by -1 and have half of the random rotation to the other direction. So let's make 2 new variables to save these rotations. One will be rotation minimum and one will be rotation maximum. So let's out drag both of them here. Let's save the value from this calculation, the division by 2, into the first one, and then the multiplication by -1 into the other directions for the next one, and back into our PCG fence. After we transform our object with the rotation offset, we'll add the random transform into the next transform points. Let's open this. Let's get actor property. Let's copy the property from our blueprint so I don't misspell it again. Property name rotation min, and then copy this and change to max and connect it to the max. Now save, and now I have a random value for each of my different uses of this spline into the level. So let's add a random rotation of 10 degrees here. You can see I break up this line already, I can have a bigger rotation. And this is the total rotation in both directions. So 90 degrees is maximum 45 in each direction. Let's stick to 20. This looks more natural. And for this fence, because it needs to connect on every post, I cannot add a random rotation. That's why if I have it into a variable here in the blueprint to control, I can use the same PCG graph for different type of object placements, because all the control is here into the level. It's not done in all of the PCG graphs into the level the same way. It's controlled by these variables here. You can extend the functionality of this placement spline with other variables or other things into the PCG graph. You can place some other objects alongside, for example. The important thing is that doing it this way, you can use the same PCG fence blueprint to create a lot of different types of object placements along a spline. Let's, for example, place some power line poles. Let's make the length like this. Like this, it's too much. Let's remove 1, 0, okay. So you can use it to place stuff like this. You can obviously rotate them a little bit. So you can see how this tool will be extremely helpful in creating some level. You can use the same spline, even out drag it a little bit more on the top. And now I'll use the bottom one instead of placing this fence here, this foundation. And this is calculating the same exact points. It's orienting them the same way. So you can create complicated looking objects just by copying this spline and placing another mesh. Concrete block 2. Let's move it between each like this. And now you have this complicated looking fence done with just 3 blueprints, 3 instances of this blueprint, and you can actually change each one separately. So if I want these concrete blocks to be rotated randomly, so you can see how useful this can be for you. I hope you like this tutorial, and please, if you have any questions, write in the comments. If you like it, please subscribe, because it will help me a lot. I'm currently looking to go over 1000 subscribers. It will be a big goal for me. So thank you guys, and hope to see you in the next tutorial. Bye.